Hello everyone. Today we team data architecture here to deal with our problem statement that is digital learning platform for rural students in Nabha. Basically, with this problem statement we can understand the lack of infrastructure which is present at the rural areas. This platform will address the issue of poor internet connectivity heads on which will be based on low bandwidth design by compressing image and videos and using the minimalistic user interface. The app will be basically on that principle offline first progressive web app PWA, which will be a like web page structure. Once the downloaded student can access the content or continue their learning offline, which will be crucial for location intermits or the internet access. This ensures that students' education isn't interrupted by connectivity issue. The platform provides comprehensive and accessible solution. We have given our app name that is Utsav Sala, which means uplifting talent, skills, aspiration, and vision. We have some integrated 5 unique points to our app, that is SMS automation tracking, which means the SMS in native language will send to their parents, which they can track their what students track their analyze the marks weekly. Then gamification. Gamification makes the subject very easy and interactive for them with the help of animation. And we also use AI integration, which will be like mini chatbots, which can they help of chatbot they can just get the quick answers of them. Then native language translator. This will be help them to translate any web page or any page to in their native language or the language which they can understand. Next we have e-library, or we can also call it as quick library, which will be open for like open infrastructure that all schools can share to them, or the which things are not available at school they can access it from there.
Shows the technical approach of our system. So this flowchart shows how our system works for different types of users, which are admin, teacher, and student, and how the backend with AI and low bandwidth optimization supports the platform. Let's start with the login. We starts with three main users, which are admin, teacher, and student. Each user login or sign up using the web interface designed with HTML, CSS, and JavaScript. The login process is validated through the Flash login, which ensures the security and authentication. Now let's move to the admin side. Once the admin login, they have four main responsibilities. First one is manage user, in which admin add, remove, or update the users, which are teacher and student. Second one is content management, in which admin upload or organize the educational material. Third one is system monitoring, in which admin checks whether the system and server work properly or not. And fourth one is report and analysis, in which admin generates the insight about the performance and usage. Overall, this ensures that the system runs smoothly and securely.
So, after a successful login and validation of teacher and student, teacher can upload the study material, which will be optimized by low bandwidth content optimization model and store on MySQL database. Then teacher can create quizzes which will be made by himself or generated by AI, in which we will use OpenAI API. Then teacher can also view the student's performance in the form of summary, which will be created with the help of Matplotlib. Then teacher can also create specialized classroom for slow learners. Then we are also planning to integrate the chatbot system for teachers so that they can take the help of chatbot for planning their further lessons and quizzes. Then we are also planning to integrate the recommendation system, which will recommend the teacher what point they can include while teaching. Now in student section, student can view the lessons, download the content that will be stored in local database. The student can also attempt a quiz that will be evaluated by using offline quiz evaluation model so that no network will be required. The students can also track their own progress, and that dashboard will be created by using Pandas, PyTorch, and NLP model, which is natural language processing model. Then we are also trying to integrate the chatbot for students so that they will get the help of chatbot for their doubt solving. Then we are also trying to personalize the recommendation system of students so that they will get the help while studying. In this whole project, we will be using hybrid AI, in which There is a cloud AI for content optimization, quiz generation, chatbots, and recommendation systems, whereas there is a edge AI for offline quiz evaluation, and we will also use OpenETL to reduce the buffering time.
Now let's talk about the feasibility and viability. We have done some feasibility analysis of our idea. First is technological feasibility. In this, we are using low bandwidth digital platforms in our app and also giving the offline content access to our user. And we are going to prepare our app in this way that it requires the low internet connectivity and it can run in every mobile, that it doesn't require the high end processor to run. Second, integration with school. It can be integrated with the existing school infrastructure and community centers and teacher led programs. Second, scalability. We are using a cloud based architecture that allows expansion to multiple schools across Nabha, and it can be also in future expanded to various colleges also, that it can also help the student to learn. Now, after this, we are talking about the potential challenges and risk and their solution. First is connectivity issues. As till now, we have seen that Nabha has a high-end issues of internet connectivity, that it can't be solved and it is not letting the children to educate in proper way. For the solution of this, we are giving offline and hybrid access. In this, we are providing the downloadable lessons access to the user, that whenever the student get a good internet connectivity in a particular area, he or she can download the videos from there, and after that he or she can access in offline mode. Then digital literacy gaps. As we know that every new technology or a new app launches, the people may face difficulties to use this. For this, we are giving training and video support. It means that we are going to provide a tutorial video in our app, that when someone downloads our app, he or she will get a tutorial video. From that, he can be get information to how to use the app. After content relevance, we know that not always a standardizable content or digital content helps to educate the people, means not always the standard language such as English is helpful to everyone to understand the things. For this, we are going to use localized curriculum. In this, we will customize our app in their native language, that it will help each and every person to understand it properly. Second, affordability. Students from low income background cannot access the high end mobile phone or high end laptops or processor. For this, we are giving device accessibility in our app, that our app can run in every mobile, that it is having low end processor or high end processor. So these are some feasibility and viability of our app.
Next, we have impact and benefit. Impact, bridging rural and urban gap. Which this will reduce the all the inequalities which the students in NAP are facing as compared to urban students. And outcome will be like interactive videos, quiz, gamified content, make concept easier to understand and retain. Empower teachers and parents. Teachers get modern technique tools while parents can actively track students' progress and performance. Sustainable model. This platform can be replicated across rural India, ensure long-term growth in digital education system. Next, we have benefit for education system, community enhance literacy and digital adaptation in rural areas, reduces dropout rates while making learning engaging, building a foundation for further edtech initiatives. For students, access to quality study materials, videos, practice tests, flexible learning, online plus offline mode of poor connectivity, gamification, and interactive tools makes learning fun. Certificates and progress tracking boosts up the confidence. Next, for student, easier to create and share, manage the lessons, better tools for evaluating. Students can save time with automated reports and assessments.
On this slide, we are looking at the research and reference that informed our project. First, we refer to the International Journal of Multidisciplinary Research by Dr. Chandramolesh GK. This study highlights some of the main challenges faced in rural education, including restricted internet access, poor infrastructure, and lack of teacher training, also a digital illiteracy. This study goals was to provide insights into the possible solutions to overcome these challenges. Next, we analyze the existing system. One major issue is inadequate infrastructure and connectivity, leading to the poor internet access. Many rural areas either have no internet or a very slow and unreliable connections. These make real-time learning and downloading content very difficult. Such platform includes Byju's, Unacademy, and Home Revise, which often cannot reach these areas effectively. Another significant problem is low digital literacy and insufficient teacher training. Many teachers struggle to use the digital platform effectively in their classrooms and need continuous supports to integrate the technologies into their teaching methods. By understanding these limitations, we can design solution that is both practical and effective for the rural educational environment.